Today's lesson is on areas of parallelograms and triangles. Take a minute to read the learning goal and scale. Find where you are on the scale before we begin the lesson. We can find the area of a parallelogram or a triangle if we know the length of its base and its height. For a rectangle, the area is the product of the base and the height. So area equals base times height. For the area of a parallelogram, it is also the product of the base and the height. So area equals base times height. For a triangle, the area is half the product of the base and its corresponding height. So area equals 1/2 base times height, or base times height divided by 2. Notice that the base and the height are always perpendicular. A base of a parallelogram can be any one of its sides. The height of the parallelogram is the length of the corresponding altitude. Remember, the altitude is the segment perpendicular to the line containing the base. In this parallelogram, the bottom is the base, and the corresponding height is here. In this parallelogram, we've got the left side as the base, and the corresponding height is here. Base times height, 8 times 4. Base times height, 9 times 6. A parallelogram with the same base and height as a rectangle has the same area as a rectangle. Here, this base is 6, its height is 4. So the area is 6 times 4 centimeters, or 24 centimeters squared. The rectangle's base is 6, height is 4, so the area is 6 times 4 centimeters, or 24 centimeters squared. In example 1, we will find the area of a parallelogram. What is the area of each parallelogram? The area of a parallelogram is base times height. The base and height are always perpendicular. In part A, we'll use 5 as the base and 4 as the height. The area of the parallelogram in part A is 20 inches squared. For part B, the base and the height don't touch each other. However, the line that contains the base, you can see, is perpendicular to the height. So let's start with the formula area equals base times height. The base is only this part of the parallelogram, so 2 centimeters, and the height is the perpendicular corresponding side, so 3.5 centimeters. The area of the parallelogram in part B is 7 centimeters squared. Pause the video and do you try number 1. What is the area of a parallelogram with base length 12 meters and height 9 meters? Since the area of a parallelogram is the base times the height, we'll substitute 12 meters in for the length of the base and 9 meters in for the length of the height. So the area of this parallelogram is 108 meters squared. For example 2, we will find a missing dimension. For parallelogram ABCD, what is the length of segment DE to the nearest tenth? We know that the formula to find the area of a parallelogram is the length of a base times the height. I can use this base and this height, or I can use this base and this height, but I will still get the same area. Since I know the length of this base and its corresponding height, let's start with those two. The area of the parallelogram will equal 13 times 9, which is 117 inches squared. Since I'm looking for the length of the height that corresponds to the base side AB, let's use the same formula, area equals base times height, and substitute the area of 117 into this equation. We know the base is 9.4, and we're looking for the length of the corresponding height. Let's call it h. To solve for h, we'll divide both sides by 9.4. Since we are to round to the nearest tenth, this first 4 is in the tenths place, so I'm going to use the 4 next to it. Since this 4 is less than 5, we're going to round down by taking all of these numbers off. Our height is approximately 12.4 inches. Pause the video and do you try number 2. A parallelogram has sides 15 centimeters and 18 centimeters. The height corresponding to the 15 centimeter base is 9 centimeters. What is the height corresponding to the 18 centimeter base? Let's start with our formula for the area of a parallelogram. Area equals base times height. Since one base is 15 centimeters and its corresponding height is 9 centimeters, we'll use those two first. Area equals 15 times 9, 135 centimeters squared. Using the same formula, area equals base times height. Let's substitute the area of 135 we just found in for A. We know the base is 18 centimeters, and we're looking for the height h. Divide both sides of the equation by 18, and the height is 7.5 centimeters. We can rotate a triangle about the midpoint of one of its sides to form a parallelogram. Therefore, the area of a triangle is half the area of a parallelogram. We can use the equation area equals 1/2 base times height, or area equals base times height divided by 2. The base of a triangle can be any one of its sides. The corresponding height is the length of the altitude to the line containing that base. In our first triangle, the right triangle, if 4 is the base, its corresponding height is 3. If 3 is the base, its corresponding height is 4. And if 5 is the base, this would be the corresponding height. In our acute triangle, if the red side is the base, this would be the corresponding height. If the blue side is our base, this would be the corresponding height. And if the purple side is the base, this would be the corresponding height. In example 3, we will find the area of a triangle. You want to make a triangular sail like the one below. How many square feet of fabric do you need? Let's start with the formula for the area of a triangle. Area equals base times height divided by 2. The base of the sail is 13 feet 4 inches long. Let's convert this all to inches by multiplying 13 times 12 and adding the 4, giving us 160 inches. The height of the triangle is 12 feet 2 inches. Again, let's convert to inches by multiplying 12 by 12 and then adding the 2 inches. So our base is 160 and our height is 146. 160 times 146 is 23,360, and we'll divide that by 2 to get 11,680 square inches. Since the question asks us how many square feet of fabric we need to convert 11,680 back into feet by dividing it by 12, giving us approximately 973 square feet. Pause the video and do you try number 3. What is the area of the triangle? Let's start with the formula area equals base times height divided by 2. Since the base and the height are always perpendicular, we can use this 1 foot as our base and our height can be 5 inches. Since we're working with different units, let's go ahead and convert 1 foot into inches by multiplying 1 times 12. Since the height is already in inches, we can leave that alone. Substitute our 12-inch base and our 5-inch height into our equation. 12 times 5 is 60, divided by 2 will give us an area of 30 inches squared. Since the question doesn't specify whether to leave it in square inches or turn it back into feet, I'm going to go ahead and convert so that we have both. To convert, I'm going to take the 30 inches squared and divide it by 12, which will give us 2.5 square feet. So the triangle has an area of 30 square inches or 2.5 square feet. In example 4, we will find the area of an irregular figure. What is the area of the figure? Notice we have a square with a triangle on top. So if we find the area of the square first, then add the area of the triangle to it, we will have the area of the entire shape. Let's start with the formula area equals base times height and use 6 for our base and 6 for our height. So the square has an area of 36 inches squared. For the triangle, area equals base times height divided by 2. We will use 6 for our base and 8 for our height. 6 times 8 is 48, divided by 2 is 24. So the area of our triangle is 24 inches squared. Now we need to add the area of the square to the area of a triangle for a total area of 60 square inches. Pause the video and do you try number 4. Suppose the base lengths of the square and the triangle are doubled to 12 inches, but the height of each polygon remains the same. How is the area of the figure affected? Let's start by finding the area of the square and then the area of the triangle. Now let's add the 72 square inch area for our square to the 48 square inch area of our triangle for 120 square inches. Since the area of our figure before was 60 square inches and now our area is 120 square inches, the area doubled when we doubled the length of our bases. Now is your chance to see how well you understand the lesson. Pause the video and do the lesson check. Don't forget to check your answers on the next slide. If you have any questions regarding the lesson check, please be sure to ask me in class. Go ahead and try the challenge now. Now take another minute to reread the learning goal on the scale. Have you climbed any higher on the scale since where you were before we started the lesson?